Please use the talk boxes.
All right. All right. So, hello. All right. So with the sharding,
Yes.
one question I have with that is how, like, if only 0.1% of the nodes are relaying a particular transaction, how am I going to know which transactions affect me? Like, if I'm just a normal wallet user, how do I know that?
Right. So if you're a normal wallet user, then chances are you'll probably be kind of a full client on only a few shards that you care about, and a light client on all the other ones. So if you're a full client on some shards, then you will be able to see kind of all of the changes to those particular shards. And because basically transactions would have to declare which shards they affect, and so you'd be able to verify those transactions yourself. Everything in every other shard you'll have to kind of light client verify with Merkle branches.
Okay. So if I like was receiving money from someone on another shard.
Yeah, so okay, if let's say I'm moving money from one shard to another shard, the approach you would take is this kind of two-step receipt approach. So the idea is that in one shard, a person would send a transaction which would basically kind of delete their ether, and it would create a receipt that's into the Merkle tree that says, look, here is a bit of claimable ether. Then a bit later, in the other shard, you would basically have a transaction coming in that contains a Merkle branch proving the existence of the receipt in the other shard. And then in the second shard, that receipt would get verified, and you'd be able to like produce a piece of ether from that shard standpoint out of nowhere. Yep.
I have another sharding question. If let's say you've got a bad actor, and their goal isn't to attack anyone in particular, but just to make a nice big mess for everybody, there will be some, and they only control a small number of machines. As long as they control enough, and there are enough transactions, there will be a transaction for which they control every single node.
So the idea here, so statistically speaking, that's basically not true, because if the shards are randomly assigned, then you can mathematically prove that if, let's say, the attacker has less than 1/3, and if you need a 2/3 threshold in order to approve a transaction, then if you have more than 100, like about 135 nodes verifying that a particular set of transactions is real, then the probability that the attacker will have enough of a majority to corrupt that transaction is basically so small that it's literally more likely that, let's say someone will guess someone else's private key, or you'll have a hash collision or something similar. So you can actually like figure out the parameters to make the statistics right to make that not be a problem.
Okay. Have you guys written that up somewhere?
The math is in like one paper that I released about a year ago, but that stuff's fairly old. If you want to do the binomial theorem math yourself, you can probably figure it out on the internet.
Okay, so then the follow-up question is, let's say there's a bug in the logic, and you figure out that there's some branch that wasn't checked by everybody.
Yes.
Is not good.
Right. If there's that kind of, like, basically, if the system breaks, then you'll have to release a software update and a hard fork to a point before it broke. So that's kind of how you would deal with any kind of sort of software glitch.
Okay, cool. Thanks.
Okay. Hi. First, thanks for coming in. We really appreciate it. My question is related to the inflation component of Ether.
Yes.
The way I understand it, a level of inflation is completely up to the discretion of the foundation.
So the inflation approach is that, so first of all, okay, I'll talk into this thing. So with proof of work, right, the inflation is about 10 million ether a year, and that's it. So that was the original plan. With a proof of stake switch, so I mean there definitely is some amount of some discretion when we end up actually launching the proof of stake protocol. But the plan is that basically once that happens, then there'll be some kind of inflation cap that's set in stone. So realistically, it'll be maybe like a few times less than what it is now, maybe even 5 or 10 times less.
Thanks. So in the case that, let's say we need to deviate from the plan, is this something that will be released to the public all at the same time, or?
Deviate from the plan in what way? In terms of like,
let's say inflation needs to be a little bit higher than expected for some reason or another.
That would probably be kind of decided in roughly the same way as other hard forks are decided. Though, it would definitely, we definitely will give sort of advance notice, and we're not going to do that sort of thing unless we get sort of broad agreement from all the developers.
Okay, thanks.
Hi. How do you prevent a smart contract, a contract which is Turing complete, from affecting any shard? Is that has that been worked on?
From doing what to every shard?
From affecting any shard. I mean, you're saying you can sort of sandbox transaction or transaction.
Right. So the idea there basically is, so right now, if let's say you have a situation where you try to call, or a smart contract calls another smart contract, but it doesn't have enough gas, so it doesn't have enough computational steps assigned, you get like an out of gas error, and so the call just pretty much fails. So the idea would be that you would have a similar kind of error, but you would call it an out of range error. So if a contract tries to call something else that's out of range given the transaction's constraints, it would just provide an out of range error, and that's it.
Okay, and just a follow up on that is, in terms of replaying the blockchain, how does sharding affect that? And if you have, say, a trusted oracle, which has a lot of data, say it's market data, tick level data.
What do you mean by replaying the blockchain?
Well, let's say with Bitcoin, you can launch a node and replay the blockchain, right?
Right. So the idea is, in Ethereum, like theoretically, you would be able to run a full node, but the only people who would want to do that would be like maybe block explorers, people like Coinbase and so forth. Like most users would have this sort of full node on a couple of shards of light node everywhere else. So they're not. So they would use the kind of light client syncing protocol to sync up quickly, download the state, and then kind of move forward from there.
Okay, but what about data from oracles? I mean, who has responsibility of?
Oracles would have the responsibility to publish that data
and storing that data.
Well, hold on. Like by oracles, you would mean like potentially a group like Bloomberg sort of publishing some prices into the blockchain. Yeah, but that's just an operation that they do with a particular smart contract. So you don't need to kind of have a special case for it.
But I'm just saying that the volume of, say, market data,
right? Okay,
per
so
second data, where is that stored?
Okay, so if you are an oracle and the amount, so the general kind of approach that I would advocate for oracles is, if your data is going to be read more often than it's written, then you probably want to just throw it all into the blockchain. But for a lot of the higher volume data providers, chances are most of the items of the data they produce are not going to be read even a single time. Like the only reason they publish it at all is because they don't know in advance which parts of the data will be useful. So if you as an oracle expect that your data will be read an average of less than one time, you don't publish it to the blockchain. Instead, you cryptographically sign it off chain. And if people want to use particular pieces of data, then they can just take them from off chain and kind of publish them into the chain themselves, and the contract will verify signature. Yep.
So I noticed that in the chart of the different plans for decentralized apps out there, that a lot of them seem like they're related to like prediction or gambling or other stuff. But it seems like as a world computer, it's got a lot of use cases. I was wondering, in your opinion, what do you think is the most promising real world application for Ethereum as a world computer?
I don't see there being one application that dominates everything. So I see like a lot of these different apps as having some utility. So prediction markets have some value. Like some of these kind of financial contracts on top of the blockchain have some value. There's people doing decentralized things ranging from kind of price stable currencies to insurance to and so forth. There's also non-financial stuff like kind of identity management on the blockchain. There's different forms of voting, some of which don't make sense, some of which do make sense. Even like management of like, in some context, maybe company shares and so forth. So I personally have no idea kind of which of those will end up not being worth it, which ones will end up kind of taking off big. So our strategy at this point is to kind of cast a wide net.
Mm-hmm. And a follow up to that, when you guys switch over to proof of stake, is there a maximum of like miners or validators?
That's still decided. So the way there might be, but the sort of parameters that we're trying to make that as high as possible. The only practical thing is that we're basically concerned about limiting the consensus overhead.
Off the back of your head, do you think it will be like a few hundred, a few thousand people?
Could be a few, right? So given the sort of technology right now, it's at a few hundred, but we have some approaches where we're thinking of trying to push it up substantially. And even if we don't, you can always kind of join sort of decentralized stake pools.
Okay, thanks.
Okay, so you were previously involved with Bitcoin a lot.
Yes.
And now you heavily work on Ethereum. I'm just kind of curious, what in that space possibly inspired you? Maybe something outside that space, a different altcoin. Like what, gave you the interest to then go pursue something like Ethereum? And
it actually wasn't from Bitcoin to Ethereum directly. So a bit before Ethereum, I got excited about stuff like covered coins and Mastercoin that were trying to kind of do next generation applications on the blockchain. And so I kind of saw that, this was, sort of 2.0. This was where a lot of the growth was going to be. And at first I was interested in some of those protocols, but then I realized that they weren't taking the right approach. So they were trying to kind of take this Swiss Army knife approach where they're trying to say, here's a list of 30 things people want to do. Let's make 30 features for them. Let's kind of explicitly support all of them. Problem with that approach is it works fine until someone comes up with application number 31. And then you have to hard fork the entire protocol. And you kind of have to do that every time someone comes up with something new. So the idea for the sort of generic programming language approach that we have with Ethereum kind of started from there. Yeah.
What would establishing a call between a couple shards look like typically?
So a call between a couple shards. So the sort of basic approach is a sort of asynchronous route where it's actually the same thing as you would do from moving ether from shard to shard. So you would basically create this kind of receipt on one shard. Then you would once that receipt gets confirmed, you would pass the Merkle branch of that into the other shard. Every shard has access to the global state root. So with access to the global state root, you can verify that, or rather, every shard has access to previous global state roots. So you could verify two things. First, that the branch is valid, and second, that you verify that there isn't a record in the second shard that branch has been kind of used yet. And so once you verify both of those, then you would launch then the contract would kind of be set up to kind of accept that kind of branch as a sort of call from another shard. If it wants to reply, then it'll create another branch, and then you kind of go back to the first shard.
Yeah. So there's a lot of comparison between Ethereum and Bitcoin. I was wondering your thoughts about how those develop over time. For example, do they each serve specific uses, or?
Ethereum is definitely taking a different. It's prioritizing like different things. So instead of like targeting particularly a currency application or a digital gold application, it's targeting trying to kind of be as generic as possible. So, in programming languages, like you often see, you don't really see one programming language ruling them all. You just see, people using Python because it's real easy to code, people doing stuff in, assembly language for high performance, and, a whole bunch of other trade-offs right in the middle. So I could see So I think, Ethereum very clearly is being used for a whole bunch of applications and people trying to sort of do custom dApps. So they're clearly seeing that Ethereum is much, much easier to develop in. But as far as Bitcoin's role as a currency, particularly as a store of value, I don't see why it can't sort of continue to hold on to that for a very long time. I'd also probably say that we're kind of taking different trade-offs, particularly on the sort of move fast and break things versus sort of be not interrupt anything at all costs curve, and both sides of that have, I guess, value.
So I was wondering if you could go back a couple slides and it looked like your EIP 105 and Ethereum 2 and 3. Mm-hmm. I guess 2 and 3 are off their years in the distance, but what about the previous slide? They didn't quite catch what release.
It's still not certain at this point.
Well, actually, what about the previous two slides? These also.
Right. Okay. So it's still not decided, but it's quite possible that we'll see like a batch of them in the Metropolis hard fork and a batch of them in Serenity. Yep.
So I don't think you mentioned this at all, but are you still planning on generalizing gas payments with any token on Ethereum?
So the EIP 101 will actually kind of include generalized gas payments, but the thing is that if you want to pay gas in using non-standard means, then you'll have to sign up miners to accept it. So
is the end goal of that, do you reach a state where Ether, the currency, has no point at all, and there's just
so first of all, in proof of stake, Ether, the currency, is still going to have a very important role because the thing you would be staking with is Ether. And the second thing is that I think it's still likely that Ether would just end up having a very large role because it'll continue being the dominant thing, even though you could pay other coins if you wanted. Like I think the currency abstraction thing is to some degree kind of inevitable because once you make the platform powerful enough, it's just going to be powerful enough to do that. And it's one of those sort of general facts about computer science that it's easy to create a platform that lets you do nothing. It's easy to create a platform that lets you do a few things. It's possible to create a platform that lets you do everything, but it's pretty much impossible to create a platform that lets you do everything minus a few things. So it's kind of Turing completeness. That's kind of once you get past a certain threshold, and often it's hard to even figure out where that threshold is. You can just suddenly unlock the entire universe.
Sounds good.
Yep.
Some folks talk about the blockchain being used for identity.
Yes.
What are your views about Ethereum and identity?
So there's like a couple of steps to that. So like Consensus has this one application called Uport, which is like sort of blockchain-based kind of decentralized like sign-on. So like I think something like sign in with Facebook without the Facebook is like one of the ways that I used to describe it. So that's the first step. Second step is that's just kind of very simple identity. It's just user defined. People can still have as many identities as they want. On top of that, the next step is to actually have like assertions on top of those identities. And those assertions could mean this entity here says that this person, is a citizen of this country with this particular unique ID number. It could mean, some other particular facts about this person. It could mean that they're a member of a particular club or whatever else. So that's kind of an ecosystem that we do want to see develop. And I see like one of the benefits of a blockchain I see as being like basically the people have these identities and you would have these assertions be recorded on a public database, done once, and then people can use them for a whole bunch of things. Yep. Yes.
So I was wondering if you could talk a little bit more about proof of stake and
Right slide.
Yeah, it feels like it's a really great breakthrough. Mm-hmm. But it's still a little bit untested, right?
Yes.
So I guess why do you think other areas of computer science haven't tried that before? Maybe they have. Like, what's the history of the research?
So there are other cryptocurrencies that have tried proof of stake models, but a lot of them they have things like nothing at stake problems. So this is a sort of fairly vague sort of game theoretic term that basically means there isn't an incentive for people not to just vote on every fork at once. So that's something that we're fixing with Casper. So the idea with Casper is that when you make a kind of bet on a particular block, you gain money in some forks, but you lose more money in other forks. So you actually are kind of staking a position and saying this block will succeed and not the other blocks. So yeah.
Yeah, that makes sense. I think let me rephrase it a little bit. So I guess how much risk do you think there is in the transition to proof of stake at this point?
I think with a change that large, there's definitely a substantial risk. And that's one of the reasons why they're doing a sort of phased rollout approach. So what we're going to do is we're probably going to simultaneously go to this hybrid proof of stake mode. And the hybrid proof of stake mode, even if the proof of stake works, the blockchain will still work fine. But the idea is to kind of test out particularly behaviors like people's willingness to put down deposits, people's willingness to bet correctly, centralization incentives, and so forth. At the same time, we're also probably going to have a kind of Olympic-style testnet probably for proof of stake, like actual pure proof of stake, run that in parallel along with the real blockchain, probably pay a bunch of ether bounties for trying to break it and so forth. So, we are planning to kind of be as rigorous with major substantial kind of changes as we were with the first release.
So one of the main talking points on the website was decentralized organizations.
Yes.
What are organizations that exist today that you're most excited to see on Ethereum?
That's one of those kind of complicated topics. It's like this concept of a DAO. It's there's been kind of myself writing about it. There's been a bunch of other kind of science fiction about it. Now, a whole bunch of people ranging from like Slock to Digix want to do them. For some of those cases, I do think, DAOs are starting to be a bit of a overused concept, and particularly the thing is that you want to do what I want to see with Ethereum is I don't just want to see people kind of replicating the old model but digitized. I want to see people coming up with new models that you couldn't come up with before. So if all you're going to do is just kind of vote on a blockchain, then that's cool, but it's not sort of as transformational as what I'd like to see. I mean, if you're on the other hand, if you look at something like Maker, where they're trying to do this sort of decentralized sort of dollar on the blockchain using financial derivatives, then that's something which is like a sort of decentralized piece of infrastructure, and some kind of decentralized governance for it really does make sense. There's stuff like, insurance is something that you sort of could be kind of peer-to-peer in some way, and organizing it as something other than as just sort of purely a protocol, it's kind of worth pursuing. There's in general, there's this things that kind of are decentralized protocols. It probably makes sense to kind of experiment with different kinds of decentralized governance layers for them, I would say. Probably things like Augur, maybe one example too.
So actually, building off of that question, core teams and the foundation itself have a very big impact on the future of the project.
Yes.
How do you see the foundation as an organization evolving over the next 5 to 20 years, as well as like the leadership structure and
Right, good question. So, one of the things that we are sort of concerned about is making sure that it's not just the miners that are or stakeholders that are decentralized, but also the developer ecosystem is decentralized, and that's one of the major reasons, probably one of the two major reasons why we went with this sort of multi-client approach with Ethereum, which is completely different from the Bitcoin philosophy, where there isn't even a yellow paper, and people, there's literally core developers that have the viewpoint that the Bitcoin core C++ code is the spec. So our approach is, basically polar opposite, which is here's a spec, a whole bunch of people implement it, and on some level you actually need more consensus in order to push changes through. But it's as so far our community has managed to kind of take something like Homestead and kind of roll it out across multiple clients fairly efficiently. I think right now, initially the foundation had a huge amount of power because it was just the only body deciding protocol rules. Over time, especially as we see Consensus, ETH Core, other companies start to take on kind of larger and larger chunks of the Ethereum infrastructure, stuff like this is going to needs to have buy-in from people in order to actually push through. And in the long term, we do want to sort of figure out some way of coordinating those things that actually is decentralized, I suppose. And we don't want to kind of commit to that right now, because right now we're still in this kind of experimental stage. We don't want to commit to a model that just might end up kind of being too hamstringing and kind of slow us down to a crawl too quickly, because that's a failure mode that people I think are sometimes coming to Ethereum to avoid. Yeah.
Okay, let's have Jen, I think.
Yeah.
So the lack of a stable coin has been talked about as a problem for mass adoption in crypto. I was wondering what your thoughts are on sort of like a dollar coin.
Yeah, so I think that something like a dollar coin would be very valuable, and I'd actually sort of just to explain a bit why I think that. So first of all, for payments, lots of people or some people are happy to accept payments in cryptocurrency, but a lot of other people aren't, and the reason is, okay, I'm some poor farmer in Africa, or some guy is earning some kind of wage, and apparently cryptocurrencies are supposed to rescue and save Africa and make the fifth world better and so forth. But I'm a farmer. I get my payment of $100 for the month, and I decide, okay, I need to buy stuff, and I get my salary 2-3 days later, start cashing it out. I go on Poloniex, and I realize, wait, my $100 is worth $63 now. Wait, how am I supposed to afford my medical bills again? So that's, the sort of thing that one of the reasons why I think that some kind of like stabler asset would be useful. Even more pressing ones, or number one, anything to do where it's Ether used as collateral. So Actually, this is probably the next two reasons rolled into one. This includes things like e-commerce. So if you have some amount of currency that's held in escrow for 3 weeks, you don't want to force the buyer and the seller to be exposed to 3 weeks of volatility risk in the middle. For prediction markets, something like Gnosis, if you're betting on, like, if you want mainstream normal people to be using your service to bet on whether Donald Trump or Hillary Clinton or whoever else is going to win the election, you don't want to force people to accept the secondary risk of wondering whether Ether will go up or down or whatever. So that if you make the bet and actually hold a deposit in some stable coin, then you remove that risk. So there's a couple of ways of solving that people are trying to do. One of them is the kind of issuer-backed coin approach. So this is some issuer says, look, I have a bunch of money in my bank account. Here are some coins redeemable for $1 each. You can trade them. Trust me. The second approach is a sort of more decentralized approach based on financial derivatives. That's the main trade-off there is it's kind of regulatorily simpler but technically harder, I suppose. Then there's kind of intermediate approaches, such as the approach that String.technology, by the way, they're still hiring, is using. This is a sort of kind of hybrid strategy that uses these multiple liquidity providers that have some connection to the real world, but also some level of decentralization between them. So personally, I am not wedded to any one of them, and I personally am happy to support projects in any of those directions with the hope that at least some of them will succeed, because I do think the problem is important.
So thanks so much for the presentation and fielding all of our questions.
Are you number -2 or number -1? I forget.
I don't remember. But what I was sort of interested in understanding your view on is effectively proof of stake is sort of akin to a virtualized Lightning network in that you're putting coins, in an open sort of state where you're putting something at stake, and then you eventually hope to make money off of it. Mm-hmm. I'm wondering if that sort of network develops, whether there be inherent competition between the folks providing that sort of second layer settlement network versus folks providing the security for the underlying network.
Oh, so you're saying, will there be sort of competition between the demand for using security deposits for stake and the demand for using security deposits to secure Lightning Network? The answer is yes, there probably will, and I guess so there will be some competition for them. One of the sort of things that I've been kind of thinking about is it possible to kind of dual use proof of stake security deposits? So simultaneously make them usable as smart contracts collateral and as collateral for staking. And the answer is potentially, maybe, we'll see. Because basically the thing that you could do is you could basically create a proof of stake deposit where the proof of stake deposit would then once you're ready to get the money back, you would get it back straight into a contract, which itself only pays it out if other conditions are met. So you could sort of have your money be held hostage for the proof of stake and for the other contract at the same time. Yeah.
Hi, Vitalik. Do you think that sort of from a 10,000-foot view, with aggressive gap times between blocks you've got 12 to 15 seconds between blocks now, increasing amount of computation, that there'll be a centralization effect where some computers simply won't be able to keep up? And then when you couple that with...
definitely something that we're kind of closely watching. Now, as you might know, one of the features in Ethereum is this sort of uncle mechanism where if your block doesn't make it into the main chain, you can still kind of get it in a later block, and you still get most of your reward. So the reason why that was done is so that basically to kind of cut down the penalty for having latency by something like 80 to 85%. Yeah. And that's something that definitely is working. So in practice, so right now, for example, the sort of uncle rate, so the percent, basically the stale rate of the Ethereum network is hovering around 7% or so. And with that mechanism, the de facto amount of rewards that people are losing is kind of down to about 1.4. So if you look at the differences between major mining pools, solo miners, it's something roughly, based on bandwidth issues, it's only a 0.5% difference in the revenues that you're making. So it's pretty well contained, and we're kind of happy with that with the approach that we took. Although, as I've said, it's something that we're keeping a fairly solid eye on.
Sure, but sort of, I didn't get to finish the question, which was, if you take into account that the original goal was to have, Bitcoin as well, is to have a decentralized, trustless platform, and we're kind of moving away from that. And then for smart contracts to be useful in the real world, you have to have oracles, and they're going to have to be trusted. And then when we take the whole single network, for example, which Bitcoin, everybody joins the same network, suddenly in Ethereum, everyone's joining a smaller network. Do you think that over time, decentralization effects are going to continue, and will the world computer actually end up looking fairly similar to what we already have?
So remember, the point of our scalability approach is actually to create a scalable network in a sort of in a very non-hierarchical way. So the network has no dependencies on supernodes whatsoever. Whereas, something that's kind of based on current technology, if you kind of try to force it to scale necessarily well. So the idea actually is to try to be sort of flat and horizontal as much as possible. Regarding smart contracts and oracles, I mean, yes, the sort of oracles are centralized, so why do you need this other decentralized thing? That's kind of an issue. That's an issue. Although, if you really care, you definitely can try to sort of use multi-sig oracles, decentralized oracles, and so forth as well. So, but even if you can't, I think that the use of a blockchain still provides some strong guarantees. So one example is that if you use oracles, it stops being possible for an oracle to cheat for specific people. They can only kind of falsify the data in the exact same way for everyone. So you still kind of get stuff that you can't get with the current system.
Thanks.
Yeah.
So just a couple of things. I'll make certain that we have links to Vitalik slides and Martin's put on the meetup page, and hopefully a video soon. And I guess one final comment. I'm always impressed when Vitalik specifically is talking that he is acknowledging that there's potential problems. I really like that humility, and I think that bodes well for Ethereum. So any other administrative questions, anything important? Thanks, folks, for coming.